This is Note-Taking Guide 4.6, Solving Systems of Equation by Substitution. So last note-taking guide, we solved the systems of equation by graphing. And although graphing works, it's not always super accurate. It's hard to get your lines to be exactly where they're supposed to be. And sometimes you feel like you're just kind of guessing that point of intersection. So today I'm going to show you how to solve those equations algebraically, where we're just going to use a method called the substitution method. So the substitution method is awesome in the fact that if you know you have an equation where one of the variables is already solved for, like in this particular case you have y equals 4x, you can take that 4x and substitute it into the other equation in place of that variable. So I'm going to substitute it in place of the y. So that 4x is coming right down here into this other equation. So that's why this is called substitution. So I'm going to have 3x, and instead of plus y, I'm going to use this value that y is equal to, which is 4x, and then set it still equal to 21 because I'm using that bottom equation to substitute into. Look how easy this became now. 3x plus 4x is 7x. And 7x equals 21. I'm just going to solve this now for x, so I need to divide both sides by 7, and I get x equals 3. 21 divided by 7, which is 3. Okay, now when we did our equations the other day on the graph, we ended up with an ordered pair, which is an x comma y value. We still need to have an xy value, so now I have x equals 3. How can I find out what my y value is? Well, I still have those two equations up at the very top that I can substitute my answer back into. So I know this time that x is 3, so I'm going to substitute 3 in place of the x, and I get y equals 12 for my solution. So again, my answer is an ordered pair. It's x comma y, so it's going to be 3 comma 12. So what this really says is my point of intersection between these two lines, if I were to graph them, is the ordered pair 3, 12. So let's try another one. This time this top equation is solved for x instead of y, and that's totally fine too. So this time we're going to take that 6 minus y, and we're going to substitute it into the second equation in place of the x. So instead of this x, I'm going to write 6 minus y. And then I'm going to write this plus 3y, and then it's still going to be equal to 18. Now this one's going to take just a little bit more to solve because now it's a two-step equation instead of a one-step equation like the other one, but that's okay. So I'm going to have my negative y from right here, plus my 3y, and then plus my 6. So I just rewrote that so that we could see that we needed to combine those together. That adds together right there to be 2y. So 2y plus 6 equals 18. You're going to isolate that y, so cover it up and see what you need to move. You need to move the 6, so we're going to subtract it to the other side. And we have 2y equals 12. Divide both sides by 2, and we get y equals 6. Now again, our answer always has to be an ordered pair. I don't have two parts to my ordered pair yet. I only have my y value. So I'm going to come back up here to the top, and I'm going to put that 6 in place of the y right there in that equation. So here we go. We'll have x equals 6 minus my y value, which is 6. When I do 6 minus 6, I get 0. So again, my answer is an ordered pair. It's x comma y. My x value is 0. My y value is 6. All right, here's another example. Again, this one is solved for x. So I'm going to take this stuff right here, and I'm going to put it in the other equation in place of the x. So this one is even just a little bit harder than the last one. We're just going to do more algebra to solve it. So right here is where it goes. It's going to be 2 times x, but my x value is 2y minus 1. So I had to substitute all of that in place of the x. Then I'll have plus 4y equals 46. So 2 times 2y is 4y. 2 times a negative 1 is a negative 2. Then I still have the plus 4y back behind and the equals 46. So I'm just going to continue to solve this by combining like terms. I have 4y plus 4y, which is 8y. So 8y minus 2 equals 46. And then this is just solving an equation like we've been doing for a long time. So we're going to isolate that y by getting rid of the negative 2 first. So add the 2 over to the other side. I get 8y equals 48. Then to get y by itself, I'm going to divide both sides by 8, and I get y equals 6. Okay, now again, just like on that other problem, now that I have my y value, I'm going to take it back up here to the top and substitute it in right there in place of my y. So I'll have x equals 2 times 6 minus 1. 2 times 6 is 12, and then 12 minus 1 is 11. So my answer has to be an ordered pair of x comma y. So my ordered pair is going to be 11 comma 6. All right, let's go on to the next one and see what we're doing next. Okay, so this one is a checkpoint, which means you need to try it on your own. So pause the video right now and try this on your own, and then push play when you're ready to see the solution. So this particular problem is solved for x. We're going to take that negative 3y and substitute it in place of the x. So we're going to have negative 3y plus 2y equals 5. We're just going to solve that by combining like terms. We have a negative 1y equals 5. To get rid of the negative 1, we divide both sides by negative 1, so we have y equals negative 5. Now again, I know what y is, so I'm going to take it back up and I'm going to substitute it in right there in place of the y. So I'm going to have x equals a negative 3 times y, but my y is going to be negative 5. So negative 3 times negative 5 is a positive 15. So my solution is going to be my ordered pair, my x comma y. So 15 comma negative 5. All right, here's the second checkpoint one. So again, pause the video right here and try it on your own. And then let's see if you can get it correct. So this one's solved for y, so all of this crap right here has to go into the other equation in place of y. So this one's already looking messy, but probably easier than graphing it still. So substituting that into the bottom equation, I have a negative 2x plus 6 times 3x minus 9 equals 42. So this is going to have some distributive property going on here. So let's not forget we got to take that 6 through to both parts of the parentheses there. So to rewrite the front, I have a negative 2x plus 18x, because 6 times 3x is 18x, and then minus 54, because 9 times negative 9 is a negative 54, equals 42. So combining like terms now with our x's, I have 16x's minus 54 equals 42. I now have to take that 54 and add it to the other side. So I'm just punching that in my calculator really fast. So I get 16x. When I add the 54 to the other side, I get that equal to 96. I'm going to divide both sides by 16. And when I do that, I get x equals 6. Now right there, if you remember, we're taking that 6 and we're pulling it up here and we're substituting it back in place of the x. So here we go. We're going to do y equals 3 times 6 minus 9. So y equals 18 minus 9 y is going to be 9 because 18 minus 9 is 9. So my ordered pair is my x comma y, which will be 6 comma 9. All right, this example right here does not have an equation solved for one of the variables. But if you look at this top equation right here, it would be really easy to get y by itself. So I'm just going to rewrite this by subtracting the 2x to the other side. When I do that, I get y equals negative 2x minus 6. So again, what I did was I took this 2x and I moved it over to the other side by subtraction. Now that I've done that, I totally have this stuff right here that I can substitute into the other equation in place of y. So I'm going to come over here and do that. Rewriting that bottom equation, I'll have 3x plus 8 times y, but y gets to be a negative 2x minus 6. And then it will still be equal to 4. This is going to be the distributive property right here, so let's rewrite it with that distributive. I have 3x, and then 8 times a negative 2 would be a negative 16x, and then 8 times a negative 6 would be a negative 48, and it would be equal to 4. So I'm combining like terms right here. I have 3x minus 16x, which is a negative 13x. And then I still have the minus 48 equals 4. In order to get the x by itself, I'm going to have to get rid of that 48. So I'm going to add the 48 to the other side. And I get a negative 13x equals 52. I'm still trying to get x by itself, so I'm going to divide by a negative 13. When I do that, it cancels over here to 1x, and over here, 52 divided by a negative 13 is a negative 4. So now that I've done that, I can totally take this and substitute it back in to my equation. So I'm going to bring it back up here to my equation that makes it look so much easier to do. So I'm going to do y equals negative 2 times negative 4 minus 6. And that gives me y equals 8 minus 6, which means y equals 2. So my answer as an ordered pair is negative 4, positive 2. So the point to this problem is that you can actually use the substitution method even if the equations are not set up for it. You're simply going to solve one of the equations for one of the variables and then use that equation to substitute it back into the other equation that you have. So it's a little bit more work that way, and in the future, maybe the next note-taking guide, I believe, I'm going to teach you how to do a method called the elimination method that works better and easier when you have both equations not solved for one of the variables when your equations are in standard form. But we'll show you that next time. All right, let's keep going. So sometimes when we're solving systems of equations, we have special cases that happen when our variables disappear. When our variables disappear, those are special things happening there. So when our variable disappears and we get a true statement, then our answer is infinite solutions. When our variables disappear and we get a false statement, then that would be no solution. So let me tell you what that means, a true statement or a false statement. Maybe on something up on infinite solutions, you get something like 7 equals 7. Maybe on no solutions, you get something like 0 equals 4, and it's a false statement. So all of your variables will cancel out, and you'll either get a true statement or a false statement. If you get a true statement, your answer is infinite solutions. If you get and we can call that all real numbers, or you can write many solutions, and if you get no solutions, you can just write the empty set. So let's see how that's going to work for us. So this is nicely set up for the substitution method. X equals 3 minus 2y. So we're going to take the 3 minus 2y and we're going to substitute it in place of the x. So we have 3 minus 2y plus 2y from right here equals 8. Now notice right there what happened. The negative 2y and the positive 2y cancel each other out to no y's at all, so 0. So we're left with 3 equals 8. 3 equals 8 is not true. It is a false statement. And if we have a false statement, then we know that we have no solution. No solution is represented by this empty set symbol. So you can just write this down, or you can write the words no solution. All right, here's our last example on our note-taking guide today. Again, this one's really nicely set up for the substitution method. So we're going to take that and we're going to substitute it in place of the y. It doesn't really matter that this time the y is on the opposite side of our equation. It's a little bit different than what we've been doing, but it's still going to work out just fine. So we're going to rewrite the 3x plus 15 and equal it to 3 times y. In place of the y, we're putting x plus 5. And we're seriously going to just solve this equation like we know how to do. So right here, we're doing the distributive property and just rewriting the rest to see what we're going to get there. So 3 times x is 3x, and 3 times 5 is 15. All right, when we start solving this, we got to move all of the variables to one side together and all of the constant numbers to the other side. So I'm going to grab this 3x right here and move it over here to be with this 3x. When I do that, though, it cancels over here and it cancels over here. So I get a 15 left over here and I get a 15 left over here. When that happens, that was a true statement. And when I have a true statement, I have many solutions. You can write many solutions. You can write infinite solutions. Or if you want to be lazy like me, you make the cursive R for all real number solutions, and you can leave it just like that. All right, that's the end of the note-taking guide, you guys. Good luck on your assignment today.